So we're back. So this is second portion. I think we'll reach until yeah, a third one. Yeah. So let's continue. So I will share the screen. This one. Okay. There. So we were cut off because of the time allocation. Now, so I think you get the idea already that this case here, this equation here is for one parameter. So I want to highlight that there's only for x1, okay? And for x1, x1 has many, in this case, can have several attributes, but in this case, only two. So in this case here, it can be true or false. In this case, true or false. Okay. And y can be true or false as well because the output y only has true or false. Okay. And in this case here, x is also x1 now. This is coming from here, true or false. So that means that we take x1 first, that is true. So like this, x1 to be true, this branch, and then go inside that branch and then consider the different outputs of y given that particular value of x1. So given x1 to be true, so what is y? So y, that's y condition. Output y given x. Okay. So what is h for y given x? Okay. So now we are given x1 to be true. And so we consider x1 to be true. We consider the two different outputs of y. Y can be true or false. So in this case here, the summation here will be this one regarding the 4 over 4 plus log 2 of 4 over times log 2 of 4 over 4 plus 0. Yeah, because this one is 0. Now that's already taken care of, multiplied by the probability of that x1 being true. So x1 being true, probability is 4 over 6. So 4 over 6 multiply this one. And then the whole thing is again a summation. So you sum again, you plus, of course, you plus this one, but it's negative, so it doesn't matter. You just go directly negative. And so the case now where x1 is false. So false, x1 is false, multiplied by when x1 is given as false. Again, x1 is given as false this side. So that's 1, that's true, 1 true over 2 possibilities. So x1 is being false, so this is the case. So that's 1, the true is 1 half, log 2 of 1 half, plus false is 1 out of 2. So that's 1 half again, log 2 of 1 half. So that is the computation. So there are two summations. This is a summation. Okay? The inside is a summation. And outside also is a summation. So now you have 2 over 6. So for x, the h of y given x1, that's 2 over 6. Okay, let's continue. So if you compute now, this brings us to the, okay, let's clear now everything, clear all drawings. And we don't annotate. Okay, let's bring us to the computation of an information gain. Okay, so this is the entropy, the absolute entropy, and the other one is a conditional entropy. Okay, so we want to use the information gain, the information gain for a particular attribute. So now this information will give us which attribute we will take first as the first layer. Okay, so we have computed already. This one is for the absolute entropy that's computed for all the y outputs. And then now y given attribute x1. So if we compute it, hy, we have already computed it before. Hy is 0.65. So now that's 0.65. And then the hy given x1, we have computed hy given x1, 2 over 6, which is 0.33. Okay. And now this is greater than 0. That means that greater than 0, we split. Okay. That means that we really have to branch it out. Yeah. But then that is a decision whether we split or not. But then we need to compare with x2 to see, that is what we are trying to do, to see whether we want to use X1 or X2 as our first layer. Okay? If you can compute X1, IG of X2, and then IG of X2 is bigger, then we use IG X2 as the first layer. If not, if this is bigger, then we use X1 as our first layer. Okay? So I didn't show the rest of the computation. It's just to show that in this case here, when your information gain is greater than 0, that means you still need to split. Okay, that's still need to branch. It is not the end of the decision. When your information gain is 0 already, that means that there's no more. You cannot split it anymore. Okay, this is the point you have a decision already. Okay? It's not possible to split further. Okay. So let's have another example. This is a more complete example to show us what will be the information gain and which layer we're going to choose. In this case here of four parameters: outlook, temperature, humidity, and windy. And the question is, we want to play tennis or not. Okay. So, well, maybe it does not apply to us because here in Palapay, people can play tennis no matter whether the temperature is very high, it's hot or mild. We don't care. Humidity is normal or high. We still play tennis, yeah? So anyway, so let's do this as an example. So I put everything here, including the equations that we need. There are two equations that we need. Okay, the information gain for each parameter, okay, the absolute entropy and the conditional entropy for each parameter. Okay, and then now this is the table that we want to consider. And how do we compute overall? So now, say, given this table, okay, and four parameters, outlook, okay, we will compute for outlook, temperature, and humidity and wind. It didn't show the rest of the computation, but we'll just do one so that we can see how it looks like, and then you can do yourself as an exercise and check whether the values are correct. Okay. Now let's start with the outlook. Okay. So we want to get the absolute entropy, the overall entropy of, in this case here, of the output Y. Okay. Output Y itself. Okay. So in this case here, there are two possibilities only, yes or no. Okay. So there are 14 records. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. There are 14 records, and how many yeses? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yeses. Okay. That's how easy decision tree is. You just need to count. You don't even count up to 14 only. Okay, so 9 yeses out of 14. So that means that in all the cases, the absolute here is the absolute entropy. So in all the cases in this case 1 to k. So in this case here, k is equal to 2. Let me annotate again so it will be faster, easier. So a summation of all the yes, probability of the yes, log to probability of yes, plus probability of the no, log to probability of the no. So yes, 9 yeses divided by 14, the total log to 9 of 14, plus then the no, of course, is 14 minus 9, that's 5 divided by 14, log to 5 over 14. So 0.94 is your absolute entropy. Okay, now let's look at outlook. So in outlook, we say overcast. So how many parameters or how many types does outlook have? There are overcast, rainy, and sunny. 3. Okay, so we consider only those 3, okay, because we look at outlook. Okay, so now our X, okay, XA is outlook. Okay, so this is XA outlook, XA outlook, XA outlook. Then we look at all those 3 types of outlook: overcast, rainy, and sunny. Okay, so for overcast, then we consider for overcast how many yeses and how many, again the output, how many yeses and how many nos. So the output for overcast are all yeses, so 4 yes. Okay, so again 4 over 4. Yeah, this is the conditional entropy. Okay, this part here inside, so it's 4 over 4 log 2 4 over 4 plus 0. Yeah, 0. So that's this whole thing, and so that's 0. Okay, log 1 is 0. Okay, log 2, log 1, log 1 to base 2. So now when it's rainy, look at rainy. How many yeses are there? There are 5 records. So 5 records of rainy, and then 3 yeses. Okay. So again, we go in here. Okay, when it's rainy, what are these probability of the output? So there are 3 yeses, 3 over 5, again like that, plus 2 over 5, and that's the result. You understand? Okay. For sunny, there are again five outputs or 5 records, and the yeses are 2. So that means there are 3 no's. Okay. So we take this. So this probability of the yes or no, given that your attribute is sunny. So the yes is 2 over 5 log to 2 over 5 plus 3 over 5, which is the no log 2 of 3 over 5. So again, you take all the possibilities of the output given all the instances of being sunny. So the result is 0.97. So now we multiply this for each of the record, for each of the parameter of the attribute or the type of the attribute. So in this case, this is the overcast. Okay, for the overcast attribute, what is the probability out of how many? You have 14. Yeah, so they have 4 records of overcast, so 4 over 14. 4 over 14, which is this one. 4 over 14 multiplied by this, okay, plus then 5 over 14 multiplied by that, 0.97, and this is 5 over 14 multiplied by 0.97. Okay, so for outlook, 0.69 is the conditional entropy. Okay, it's just substitution only. So of course, we're not familiar with the equation. I think the most crucial part here is to understand exactly what do we need to input here. Okay, to understand exactly what is the equation, so that you can interpret, you can plug in the information from the table. Okay, once you're familiar with that, it's just counting on. Okay, for sure you know how to count. Okay, so that is the first case for the outlook. And then if you go to the other case, let's clear all drawings. Okay. So now if you go to temperature, so again, you have in temperature, you have 3 types: cool, hot, and mild. Yeah. Cool, hot, and mild. And so for cool, again, we know how many items are, how many instances are there for the type cool of temperature. 1, 2, 3, 4. So there are 4 records, and how many are yes? So that's 1 yes, 2 yeses, and then cool, that's a no. So there are 3 yeses. So there are 3 yeses. The computation is not shown. You can do your own computation by plugging in the equations here. Okay. And then for hot, again, the 1, 2, 3, 4. 4 cases of hot. Okay, you want me to, let's compute? You want me to compute? Yeah, let's compute. So what is this? So, okay, so for our, so that we don't, I know you're not even computing in your, okay, can I see who's computing in the paper? Who is computing? Okay, let's compute. Okay, let's compute, and then you show me the paper at one time, and then if there's nobody not doing a paper, we'll minus the attendance. Okay. Okay. Let's compute. So now you have 4 records of cool, and then there are 3 yeses. Okay. So that means that if you take the conditional entropy of this one being the x parameter, the x temperature, XA, okay, we take first XA, the J to be cool. So that's cool case. Okay, for the case of cool, how many yeses and how many no's? So for case of cool, there are 3 yeses. So that means that this is 3/4 because there are 4 records. Okay, the yes first, log 2 of 3/4 plus the no case for the cool case. I mean the no output for the cool case. So that's will be no 1/4, then log 2 of 1/4. Can you please compute how much is this? Okay, it will be easier in MATLAB. I mean, you're just using your computer. If you can open MATLAB or Octave, you can just do 3/4 times log 2, then parenthesis 3/4 like that. Can, okay? See if that is equal. Okay, and the other case, of course, this is negative. Ah, no, it is not negative yet. The negative will be after. Undo. Okay, because we are still inside here. So now next is this one, 4 records 2. So that means in the case of hot, so there are 2 yeses over 4 records. Okay, log 2 of 2 yeses over 4. That's 1/2. So okay, plus the no will be 2/4 log 2 of 2/4. Okay, this is 0.5 plus 0.5. Okay, check. How much is that? And then here, there are 6 records of 4 yeses. So the case of 4/6, log 2, because that's the yes for the mild, 4/6. And then the no for the mild will be, of course, the one that is not yes. So that's 2/6, log 2 of 2/6. Okay, and that's equal to that one. Okay, so here now we multiply. So 0.81 multiplied by 4 cases out of 14. Okay, so you have 4/14 here. It should be 4/14. Okay, if you just write out the whole equation here, 4/14 negative, and then here will be uh, here will be 4/14 as well. And then it's negative, negative. Then this is 6/14. Okay. And then we add everything. We add this one. We add this one. Okay. And the result is 0.91. Okay. So that means that this is a conditional entropy. And if you take the information gain, Ig is equal to 0.994 minus 0.91. That means it's very small. Okay, 0.03. Very small entropy. So temperature is not very high entropy. It's not our first priority to have a layer because it looks like it is more definite. So in this case, what about this one? So the Ig for this one is 0.699. That's a lot higher. So that means the Ig for the previous case of outlook will be 0.94. Okay, minus 0.69. How much is that? So 14 minus 9, that's 5. So 8 minus 6, that's 2. Okay, that's a lot higher, 0.25. So that means comparing between outlook and temperature, okay, sorry, outlook and temperature, then our temperature has lesser entropy, then outlook will be the one of our choice. Okay, but of course there are many other parameters. So if you take humidity, okay, they didn't show the example for humidity and wind, but they just give us the result. Okay, so just so how we are going to compute. So now this is 0.25, as we mentioned, this was highest gain, and then for temperature 0.03. And if you compute the same thing for humidity and wind, you can see humidity is also quite high, but not as high as the outlook. And so the highest gain is the outlook, and so the first layer will be outlook. Okay, so now let's continue. Did I record? Am I recording? Yes, I'm recording, yeah? Okay. Okay. So now, let's look at the case of whether we really want to play tennis or not. How come this one, you cannot move? Move. Okay. Okay, so the first, the root, normally, yeah, we'll have a first root, we call the stump of a tree, which is the overall output of yes or no. So in this case, you want to play tennis, 9 options of 9 answers of yes and 5 answers of a no. Okay, now what is the first node? Okay, the first node, we have chosen it to be outlook. Okay, so outlook, we already chosen it because we say this is the highest information gain. So now outlook. So when to play tennis, there are 3 outlooks. That means it's overcast, rainy, and sunny. Just like overcast, rainy, and sunny. Okay, that's why there are 3 branches. Okay, so now how do we continue from here? So we need to again consider what will be the next branch. Okay, so in this case, the outlook of overcast, it is already determined. Okay, if you compute the information gain here, it will be 0. Okay. Why? Because it is already definite that there's 0 in one case and 1 is positive, or both 0 also, you know, there's no, it is indefinite. Normally it's not, it cannot be both 0 because there's an output, or 1 or both 1, you cannot split as well. We will show it later, but in this case here we don't need to split it. Okay, by looking at it without even computing, we know that this is already there is already a decision. Okay, that means that you want to play tennis when the outlook is overcast. Definitely, you will play tennis. Okay, it doesn't matter whether it's windy, it's humid, or temperature is high. Okay, the person will play. Okay, according to this data. Yeah. So now. You want to play. Now there are 2. Now we are left with 2 options. Yeah. We'll look at the case of rainy, when the outlook is rainy, and the case of when outlook is sunny. Okay. So how do we do this? Which data are we considering now? So we look at this table. Okay. We have already considered the entire table where we consider overcast, rainy, and sunny. Okay. Now, because there's a decision there regarding outlook, we don't consider outlook anymore. We're done with it. Okay, so now we consider given outlook that is overcast will always be yes. We ignore this. Okay, no more. Okay, no need to compute this. It's definite. The answer is definite. Now we consider the next case, the sub table when the outlook is rainy. So now we concentrate only in this part. Okay, for this particular node. Okay, how do we branch for this particular node? And then we consider also this part, the outlook when it's sunny, and then we consider only this subtable. Okay, and then we can continue from there. Okay. Okay, but we need to know what will be the next layer. Okay, so let's look at here the rainy. Okay, the rainy outlook. Which one will be our next layer? Whether it's temperature. Okay, I mean the next node. Yeah, the layer. Will it be temperature, humidity, or wind? Okay, or windy. Yeah, so now we're going to compute. Okay, can you please compute this one? Okay, so for temperature, there are 2 records. So that means that 2 records out of how many? 2 records, okay, sorry, for temperature, okay, there, okay, we use this table, yeah? We consider only this table so that it will be much clearer. and we look at temperature. Okay, so for temperature, there are two cases only here. There are not three, although there are three cases for the overall, but in this subtable, there are only two. So 1, 2, 3, 4, 5 instances of, of, uh, of the outlook being rainy, and the temperature being cool has 1, 2, 2 instances, 2 records, and of these 2 records, 1 is yes. Okay, so that means what? Okay, the overall probability of all the case here, there are 2 out of 5, that's 2 over 5. And then the overall records for the mild, there's 3 over 5, so 3 over 5. We consider only this part, okay? Okay, we choose one attribute, one type of attribute of the temperature, and we look at all those in this case, 2 types of cool and mild, and then what is the probability of that, okay? So there are 2 instances out of 5 and 3 instances out of 5. That's the one that's taken care of. So now we go into cool. So cool, what is yes? How many as yes and how many are no? So that means that there's 2 records and 1 yes, okay? So that is 1 over 2. That's yes, log 2 of 1 over 2, plus, of course, the no, log 2 of 1. Yeah, log 1 half, log 2 of 1 half. Okay, plus the other case of the mild. So in this case, there are 3 instances of the mild, and 2 are yeses. Okay, so that means 2 over 3 for the yes, given the mild. So 2 over 3 log 2 of 2 over 3 plus 1 over 3, which is the no, 1 over 3 log 2 of 1 over 3. Now, can you please compute how much is this so that we will know what will be our, we are only looking at this branch, okay? See, the computations are not that extensive, but it's just tedious. Hello? Can you tell me how much is this? And the same thing, we'll look at humidity. Humidity for this particular subtable. Okay, so in this case, there are 2 types of humidity, normal and high. Okay, only 2 types, normal. It's been always 2 types, normal and high. So that means for normal, how many instances are there? 1, 2, 3. 3 records, and how many are yeses? 2 yeses. Okay, so overall normal is the overall probability, which is this part here. Normal is 3 over 5, so that's 3 over 5. That's done already. And then high is 2 over 5, so 2 over 5, that's done already. So multiplied by the one inside, how many yeses are there given normal, excuse me. So that's how many yeses for normal? 2 yeses. So 2 over 3 log 2 over 3 plus, of course, no, 1 over 3 log 2 of 1 over 3. And then for the high, how many yeses are there? Out of the 2 records, there's 1 yes out of the 2 records. So again, 1 half. 1 half log 2, 1 half plus 1 half log 2, 1 half. Okay, so how much is this? Please compute. Nobody's computing. I'm running out of time again for 10 minutes. Anyway, so now for windy, there are 2 records and 0 yes. Okay, so that means 2 over through, that is all, everything is no, log 2 of 2 over 2. But then the overall probability, here there are 2 records of a wind, in the 2 records of a true. That's 2 out of 5. I want to remove this one. Okay. 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 So there are 2 over 5. So that's true. For windy, so we look at windy, and 2 out of 5. So 2 over 5 for absolute. This is the one absolute probability. And then now here 2 over these 3, so 3 over 5 absolute probability. And then now we look at the record of true only, so everything is no. So that's 2 over 2 log 2 over 2 plus 0, of course. And then when it is false, and then there are 3 yeses, so this is for the yes. 3 over 3 log 2 of 3 over 3 plus 0, because there's a no. The no, there's 0 for the no. Okay. So this one log of 1 is 0. So this was all 0. So this one will be 0. So that means most likely this is the highest conditional, information gain. Sorry. That should be the highest information gain, because information gain is the absolute entropy divided by minus the conditional entropy. So here is equal to 0. How much is this? Can somebody compute how much is that? That's 0. So IG will be, okay, what is the IG? H of Y. H of Y for the whole thing. Outlook, this one. 3, okay. 3 over 5 plus, how much is the HY of this one? This is the H of Y. This is a H of Y. How much is this? Can somebody please compute? Minus this one. Minus this one, that's one option. Minus this one, another option. Minus this one. This one for sure, I think, is the one that will be the next layer. Can somebody compute? No? Ah, okay. Let me compute. Okay, wait. Let me do octave. Okay, there's no Miss Kisobaka here. Miss Kisobaka is the one that's always computing for me. Okay, now we put the note. Okay, there, let's compute. And then let's remove the annotations. Annotation, clear all drawings. Okay, so now remove this one. So where were we? This one. Okay, so log 3 over 5 times log 2 of 3 over 5 plus 2 over 5 log times log 2 of 3 over 5. Okay, ano, 2 over 5. Okay, is that correct? Okay. So this one, but then there's a negative sign there, so that means that one is, that one, the first one is 0.97. So that's 0.97. And then this one, the second one is, let's just do minus 2/5 times the one inside, 1/2 times log 2 of 1/2 plus 1/2 times log 2 of 1/2. Okay, that's done. Okay, plus the parenthesis there. That closes the first summation. And then now minus, okay, just put minus 3/5 times, then open parenthesis, second summation. We have 2/3 times log 2 of 2/3 plus 1/3 times log 2 of 1/3. Okay. Okay, can someone write it down? So the first one is 0.97. Okay, let's put it here. Text. Okay, I want a notepad. Let's move this one. So that means this case here, the first one, okay, let's put it here. Because here, this is our, the first case, this first case is 0.95, very high. Okay. Of course, the absolute entropy is What was that? 0.97. Okay, that's absolute one. And then the first case is 0.95. And then let's do the second one. Okay. Now let's paste. Okay. So the next one is minus 3/5. I think it's the same. Minus 3/5, 2/3, log 2, 2/3. There's something wrong here. Let's recompute this 2 over, it should be, it's not 2.3. Okay, 2 over 3, log 3, 1 over 1/3. Okay, let's compute that again. It's still this 0.95, okay? So the other one, I think this is just an exchange. This part here is this part, and then this part here is that part. So they have the same. So this is 0.95. And then let's confirm this one. So the third case is that you have 2/5. Let's just compute it, although we know that this is 0. 2 over 2. And then 3/5 times 3 over 3. Okay, then that's 0. So this one is 0. Okay, so the information gain is 0.97 for the first one minus 0.95. So the information gain for the first one is what? 0.02, right? And the next one is again 0.02, and the next one is 0.97. Okay, so that means in this case here, from the outlook, rainy, your next layer will be this one, windy. Okay,